So what you're going to do with this sheet is you're going to take it and you're going to fold it in half. Right down the middle. Okay? And then you should get this nice little front page, and then if you turn it sideways and open it, we've got some examples we're going to talk about inside. Okay? First, we want to worry about this front. Okay? So, now let's start off with the first column. We're given two functions down here. F of x equals x plus 3, x minus 1, and then we have a square one down here. Don't freak out. This shouldn't look too scary. Okay? But this should look very familiar to you. All right? Now, in our warm-up, we talked about roots briefly. Someone mentioned roots, okay? Roots or we find roots and write them in coordinate form, okay? Roots are this terminology, which is basically m, 0 plus and n, 0. N and m being the numbers that we get from here. Now, the signs on roots flip. Yes. Huh? You can't see? Thank you, Allison. Are you going to see where he's sitting? Okay. If you guys want to swap, that's fine. I'll switch in the seating chart. All right. So when we plug in for roots, however, okay, I'm going to put this down here. Be sure to flip the signs. What do I mean by that? So this says x plus 3. What we're going to write down instead is -3, 0. This is m, this is n. Hopefully some of this is coming back from memory. Okay? And then the other one, what would be the other one? 1 and 0. Here we go. All right? Now, when we talk about max and minimum, so we're going to go across the row this way. Okay? When we talk about max and min, we talk about which value a is positive. A is the leading term in front of the function, meaning whoever's at the front of it, and usually in front of an x squared. Okay? We'll see more complete versions. So a lives right here. As I said, he's right in front. There's no a here, but there is implied positive 1. If it is positive, so it's positive, that means it's up. And if it's up, that means it's a minimum. Okay? Now, the axis of symmetry, or AOS, is what we abbreviate this as, is found by using this equation. Okay? And, I forgot to write this in here. You write the answer as x equals. Okay? I'll put ANS dot for short, abbreviated. Answer as x equals. So if we were to plug in those information, our m was what again? What's m? 3, yep. So it'd be, but it's -3. So we're plugging in the value after the flip, not here. We're plugging it in here, okay? Plus, what helps bring that down is when we look at the parent function, which is x minus m, x minus n, the terms should definitely flip, okay? Everybody see that? So it would be x minus 3 plus 1 divided by 2. So we get x equals -1. And that would be our axis of symmetry, meaning that if we were to draw that line on the graph, it'll cut this guy perfectly in half. We can fold him over. Okay? This is x equals -3 plus 1 over 2. We're literally plugging in my m and n values from here. Okay? So, vertex, all right, you write your answer in coordinate, you write your answer here in coordinate form. I forgot to write that in last night. So you write your answer in coordinate form. Okay? So what we do here is we plug in the axis symmetry for the x value to find the y value. So we're plugging what we found here to get the vertex. If you do the axis symmetry wrong, the vertex is going to be wrong, obviously. So we plug that in. We're going to have y equals -1 plus 3 times -1 minus 1. We solve that out, we should get 2, -2. So we get y equals -4. So that means our final answer will be -1, -4, and that's the vertex. So what I did was I took the equation, the function itself, and plugged in the axis of symmetry. I then get -1 plus 3, -1 minus -1 minus 1. -1 plus 3 is 2. -1 minus 1 is -2. 2 times -1 is -4. And I put in coordinate form where my given value was -1 was x, and my new value was y equals -4, and I put it in coordinate form. Okay? Now, granted, most of you guys in the end game are just going to graphing these things and finding the stuff by looking at the graph. This is the math behind it. Yes. Sorry, I had a little typo. This is y equals -4. Y equals -4. Okay? So, let's talk about the intercept, though. Huh? All right. So to find the y-intercept, it's simple. All we do is plug in 0 for x. Duh. We want to find when x equals 0. Y-intercept is when x equals 0. Y-intercept is when x equals 0. Okay? Plugging x equals 0 into the equation, solve for y value. So we're going to go again. Y equals 0 plus 3. We're going to have 0 minus 1. I get 3 and -1, which means y equals -3. So my final answer is 0, -3. Yay. Okay. And unfortunately, when I did this, I did not fix the margins on this. So on your papers, this should be a parentheses right here. It got cut off in the table. So just might want to write that in. It's kind of snug. So we need to fix that at some point. So for the domain, it is always -infinity to infinity, which is also classified as what? What do we call it when we have something from all numbers? What is that called? Does anybody remember? Give you a hint. It starts with real, or has real in the middle. All real numbers. All real numbers means infinite, -infinity to infinity, i.e. all real values that are possible. You need to remember that from the number system. Okay? We describe that as, or 2 lines and an R. That is the all real numbers symbol. Fun fact, there is a symbol for every single type of number system. Integers, irrational, etc. Every single one has one. I think if I remember correctly, there's approximately 6. Because some equations, some functions only work with specific types of number systems. I.e., if I don't want all the negative numbers, then I want the number system that includes positive value numbers, which I can't remember off the top of my head what it was called. I think it's called integers. But the real number system includes negatives. One number system does not include negatives. So a little extra information there. And finally, the range. That negative should be inside that parentheses. Sorry. So that needs to be here, and that does not need to be there. So I forgot to typo this last night. I wrote this at like 10, 11 o'clock. I had to type it from a template because the template got all messed up. So, and for this one, finally, it is the minimum at -4. Okay? So we're going to put down -4, positive infinity, and we're done. Congratulations. That is how you write out all the information for the graph. Yes? Yes. That's all the negative x values. It's the domain. Or then all the negative y values if it's range. Okay. So, this shouldn't be too scary. Let's take a look at the other one on the bottom. Okay? For the other one, I have 2, 0 for this one. Okay? Why? Because I'm not given an x minus n. I'm only given an x minus m, and it's squared. So I'm not going to have another coordinate pair for my roots. So what that means is this. Only one x-intercept. Happens twice. It happens twice and bounces at 2, 0. Okay, so happens twice, bounces at 2, 0. That's what that basically means. All right, so this one, again, doesn't have a negative value in the front, okay? So since it has a positive a, which is 3, it has a positive, so it's up, so it's a minimum. Our axis of symmetry would be x equals
teachers, at this time, we would like to start calling for pictures for the makeup picture.
Sorry about that. All right, so we plug in this. It's 2 plus 2, okay? Over 2. So we get x is equal to 2. I just saw a typo. So, since there is no n on this should actually be 0. Yes, hold on. All right, so And I need white out. But for now, I'll cross this out. So this is actually 2. And the reason why is because it bounces twice. So we have to include it twice in terms of the roots. If you feel like you're going to mix that up, make sure you have a graphing calculator in front of you, plug in the graphing calculator, and find out where the vertex is. That's going to be your axis symmetry, and it'll always be the x value. Okay? So, as far as our vertex, Yes. Leave your phone, sign out. Y equals 3 times 2 minus 2 to the square value, 3 times 0 squared, which is just going to give me y is equal to 0. So my vertex is going to be 2, 0. For the y-intercept, we're going to plug in 0 to find it. Y equals 3, 0 minus 2 squared, 3, negative 2 squared, 3, 4 equals 12. So it'd be 0, 12. Domain is always negative infinity to infinity, or all real numbers. Finally, it is a minimum at 0. So that means that its 0 is included, and it is positive infinity all the way up for the range.